Hi, this is Mrs. Kidman, and in this video, we're going to be discussing different lines, segments, rays, and points that go through triangles. Now, there are 4 different lines or segments and 4 different points that we're going to discuss, but there are going to be some that are more important than others. So I will make sure that I highlight those, but really what those ones are medians, centroids, altitudes, and orthocenters. Oh my, look at those words. They're fantastic things, and they have fantastic properties when it comes to triangles. And so I'm so excited to explore them with you. But let's first take a look at some of these different segments, lines, rays, and points in triangles. Now, these first few that we're going to cover are actually things that we covered in the last section. So very first, let's talk about the perpendicular bisector in a triangle. Now, the perpendicular bisector in a triangle is a line or a ray or segment that bisects or divides exactly in half one of the sides of our triangles. And as it intersects with that side of our triangle, it's actually going to cross at a 90-degree angle. So you can kind of see that here, 2 equal sides, 90-degree angle. That's why it's called a perpendicular bisector. Perpendicular because it crosses at a 90-degree angle. Bisector because it divides it into 2 equal pieces. Now, when we take the perpendicular bisectors of all 3 sides of the triangle, all those sides will actually cross at one specific point. And the specific point, which is also known as the point of concurrency, is called the circumcenter. Now, that circumcenter is where it crosses, and it kind of has some cool properties about it. So the circumcenter of a triangle is actually equal distances from the vertices of a triangle. So here, right here, this point P is our circumcenter. And notice how it's exactly equal distance from our vertices. It doesn't matter which vertex we're looking at, whether it's point A, B, or C. Whichever vertex we're looking at, it's equal distance from those, which is really interesting and cool. Now, another one that we're going to talk about is called an angle bisector. Now we address those. Angle bisectors are lines, segments, or rays that split an angle exactly in half so that it's the same degree on either side of that line. And when we find the angle bisector of all 3 angles in a triangle, we actually get a point that they all cross at, that point of concurrency, called the incenter. And the incenter of this triangle is actually equidistant from the sides of the triangle. So the circumcenter is equidistant from the points, while the incenter is actually equidistant from the 3 sides. And notice how when it crosses those 3 sides, it's actually equidistant at a 90-degree angle, which is really cool. So that is something awesome to be aware of. Now, the next few things that we're going to talk about are really important, and so they kind of get their own slide. Very first, let's talk about the median of a triangle. So the median of a triangle is a line that starts at the midpoint of the side of the triangle and goes to its opposite vertex. So the midpoint means it divides it exactly in half. So here's our midpoint, which means the 2 sides are the same, and then it's going to go to the opposite vertex. Okay, so that's our median. Now, if we were to take the median of all 3 sides, just like we have been, we would get the point of concurrency called the centroid of the triangle. That's right, centroid. It sounds like droid, but it isn't. Ooh. So we have that centroid of a triangle. Now, this is the point where all the medians meet. We can see it in this picture, it's point P. And it actually has a couple interesting properties. It's always inside the triangle. And it's 2/3 distance from the vertex to the centroid. So this would be like 2/3, and this is 1/3. And this piece is 2/3, and this is 1/3. And this is 2/3, and this is 1/3. Now, what is it 2/3 and 1/3 of? Well, it's that whole distance of the median. So if they tell us that the median, or in this case, like BF, was 21, then from B to P would be 14, and P to F would be 7. It's always going to have that 2-to-1 ratio from one end to the other, with that centroid being in the middle. So the longer piece is 2/3, the shorter piece is 1/3. And that's always really awesome. The other thing to take note of is remember the definition, or in the description of a median, it says that it starts at the midpoint, which means that our sides here are actually going to be congruent as they're split up. And so that can be super helpful when we're given just one small bit of information or 2 small bits of information. We can actually use that information to determine what the rest of those side lengths are. So if we're just given BE and we're just given BP, I can actually figure out PF, I can figure out EC, I can figure out BC, and I can figure out BF, all just knowing those 2 bits of information, which is really cool. Okay, the last type of lines that we're going to talk about and points in a triangle is called the altitude of a triangle. Now, the altitude of a triangle, when we think of altitude, we think of height in the real world. Now, altitude of a triangle is exactly what it is. It's the height of our triangle. So think of when we had to calculate the area of a triangle, and we do base times height divided by 2. Well, that height that we were calculating was actually the altitude of the triangle. We just never called it that. We just called it the height. So what the altitude is it's the perpendicular segment from a vertex to the opposite side of the triangle. Now, depending on what the triangle looks like, sometimes that altitude is inside of the triangle, like we can see with this one. But with the scalene triangle, it's actually on the outside in this case. And so it has to go to the opposite side of that triangle, or it's really like the opposite side of the triangle or line that extends from it. Okay, that's really what we need to think of when we're thinking about that. It's not just the opposite side, but it's like it also can go past that. Now, the altitudes of the triangle, we talk about how there's an altitude here, there's an altitude here, there's an altitude here. They actually are all the same distance because the height of our triangle is the same. But that point where all of them meet is actually called the orthocenter. And the orthocenter is very special because we can actually get an orthocenter inside a triangle, like you can see here with an acute triangle. It can be on the triangle. So like this right here is our triangle. You see this? And it's in that right angle there. It's in the triangle, like literally on it, on top of our triangle edge, which is cool. Or it can actually be found outside. So again, this here's our triangle. And in this case, our orthocenter is right there. How crazy is that? And so that's kind of what it is. There's not really a linked relationship from the side to the vertex, like there have been with some of these other ones, or from that orthocenter to any of the other points. But what it does have is that we know that that point is either inside on the triangle or outside, depending on what the triangle looks like. So if the triangle is acute, so all the angles are less than 90 degrees, then it is going to be inside. If there's a right angle in it, so a right triangle, then it's on it. If it's an obtuse triangle, which means one of the angles is more than 90 degrees, then it's going to be on the outside. Pretty cool. So here is just another picture to help you visualize that. So that, again, that orthocenter, where it's concurrent with those altitudes, that point where all our altitudes cross, can be inside, on the triangle, or outside. So please check out the next video in which we're going to address how we can calculate or figure out where the centroid is when we're given a triangle on a coordinate plane. Talk about how we can decide where the altitude is going to be of a triangle, depending on what it's given to us or where that orthocenter is, and also how we can use the medians and the properties of the median and the centroid to determine what different side lengths are or pieces are in a triangle. So please check out how we can apply these interesting things and what we can do with them in future videos. If you have any questions, feel free to reach out and I will hopefully get back to you as soon as possible.